Hello friends, welcome to TechCube Gate classes. My name is Professor Vivek Singh Rathore and I am dealing with signals and systems subject. Till now we have completed module 5 and we are in module 6, that is Z transform. And in the past two lectures I have dealt with Z transform of some standard signals and some properties of Z transform, introduction of Z transform, how do we convert from S plane to Z plane. These all we have seen. Now what we will see some more properties and then some more theorems in this. So we'll see. Let's start our session today. We'll start with properties of Z transform only. Properties of Z transform. Okay, fine. So see, properties of Z transform. First property we'll see, that is linearity property. Linearity property, as we have seen in the various domain, like see in the Fourier series also we have seen Fourier transform also, Laplace transform also. Everywhere they were following linearity property. For linearity property, you know that two principles should be followed, that is principle of homogeneity and principle of superposition. These two conditions should be satisfied for linearity condition. Let's suppose your signal is f of n, and let's suppose f1n is there, so we'll get f1 of z, we'll get f2n, another signal is there. If we'll take Z transform, we'll get f2z, let's suppose. And if we'll combine both signal f2n, okay, and then we'll send Z transform, what we'll get, if we'll get f1z plus f2z, then we say that this follows superposition. Okay, so Z transform follows it, so we can say that superposition theorem is satisfied. Now let's suppose you have given f of n as input to a signal. If you have taken Z transform of f of n, you'll get f of z. Okay, and let's suppose you have multiplied a scalar quantity in this like this, and then you have taken Z transform, and if you get the same quantity here also in the Z transform also, then you can understand that this property satisfies homogeneity. So Z transform satisfies both. That is why, therefore, final we can say that a1, let's suppose f1n is there, है plus a2 f2n is there. If we will take Z transform, we will get a1 f1z plus a2 f2z. This is the whole sum or summary of linearity property. So linearity property, I think you have understood this linearity property. Now we'll go on with the next property, that is multiplication by exponential function. Like see, if multiplication, I will write here multiplication by exponential function. Okay, so let's suppose f of n is there and we'll take Z transform. So what will happen, we'll get f of z, let's suppose we are multiplying e to the power j omega 0 n to the into f of n. What we'll get, we'll get f of z minus e to the power j omega 0, no, we won't get like this. Okay, so you should not think, as we know that we are only multiplying exponential function. Like see, now only we in the last lecture we have seen a to the power n into f of n, or like see a to the power n u of n, you have seen already that it will be 1 minus a z inverse, or you can say that z by z minus a with ROC z is greater than a, like this. So here also you can think that it is e to the power j omega 0 to the power n is there, and your f of n or u of n you can consider. Let's suppose that we have multiplied the signal in this. So what we can write here is, see, 1 by 1 minus e to the power j omega 0 z inverse, so you can write it as z by z minus e to the power j omega 0. And where will be ROC? See, ROC will be here mod z, or we can say mod z minus e to the power j omega 0 है ना, should be greater than 0. So see, mod z should be greater than, see, mod of e to the power j omega 0, you know na, e to the power j omega 0 Euler function cos omega naught 0 plus j sin omega naught 0 है ना, e to the power j omega naught 0 is nothing but cos of omega naught 0 plus j sin omega naught 0. So as you know that the modulus of this function will be equal to 1. So we'll take here as mod z is greater than 1. So finally what we get here is mod z is greater than 1. Okay, so see, now you understood that whenever you multiply e to the power j omega 0 n to into u of n, you'll get like this function. Okay, now same function, if I will multiply e to the power minus j omega 0 n into u of n, what you will get? You will get definitely z minus e to the power minus j omega 0 with mod z is greater than e to the power minus j omega 0. So whatever it may be, e to the power minus j omega 0 or e to the power j omega 0, the modulus function will be, mod value will be 1 only. So it will be 1 only. So ROC for e to the power j omega 0 n u of n you have seen, e to the power minus j omega n u of n you have seen. Now see, if we'll multiply these two, I'll mark it, I'll highlight it this point. See, this is worth to be remembered. Okay, so this portion है ना. Okay, and here we can say e to the power minus j omega 0 and this one is also worth to be remembered. You, because see, from here we'll get some more thing like, see, e to the power j omega 0 n है ना, uh, uh, we know that its z transform is z by z minus e to the power j omega 0 with mod z is greater than 1 है ना, and if we'll plus e to the power minus j omega 0 n है ना, so according to linearity property it will satisfy both conditions. So e to the minus j omega 0 with mod z is greater than 1 है ना, and if we'll multiply half here है ना, so obviously here also half we have to multiply. Okay, so here what we got here, it can be said, it can be written also as cos omega 0 n है ना, cos omega 0 n, and you can write u of n है ना, its z transform is nothing but half of z by z minus e to the minus j omega 0 or z minus e to the minus j omega 0. So this if you will multiply है ना, this if you will multiply, if you will cross value here and we will do, so final value we will get is as z square minus z cos of omega naught है ना, and in downside we will get as z square minus 2z cos of omega naught plus 1 है ना, this value. And where will be the ROC value? ROC value obviously it will be mod z is greater than 1. So this is very important. As I have told you in Laplace transform also, you should remember cos omega naught t sin omega naught t. Here cos omega naught n sin of omega naught n you should remember. The same goes with the sine of omega naught n also. Like see, here we have done plus, here we will do minus. Like see, we'll write here e to the power minus j omega naught n is there. Okay, and I think first we will take e to the power plus j omega naught n है ना, and then we'll write here its z transform is nothing but z by z minus e to the power j omega 0 है ना. Okay, and if we'll plus no minus e to the minus j omega 0 n, so what we'll get minus only z by z minus e to the power minus j omega 0 है ना, and mod z will be greater than 1 only. If we'll do 1 by 2j है ना, so here also 1 by 2j will we have to do. So we will get here as sine of omega naught n u of n है ना, and here we can write as 1 by 2j and we will cross multiply and we'll take LCM. So what we'll get here is z of sine omega. You should solve it. I'm writing the answer. Z sine omega z square minus 2z cos omega naught plus 1, and its mod z value is greater than 1. So this value is also worth remembering. This value is also worth remembering. Okay, so you should remember this formula. So I think now you must have understood that what we were discussing till now. See, first of all, linearity property, and that property has been used in this also. First of all, we have seen multiplication by exponential function. So e to the power j omega 0 n, है ना? So what we got is like, see, I'll erase it. It is not of use. So see, okay. So a to the power n u of n. As we know, it was like this. So we have done like this: a to the power n u of n. We have done this. So from here and from this portion, we have got cos of omega naught n and sine of omega naught n value. Okay. So see, now what you understood, that by properties of Z transform, we have seen the linearity properties also, and we have seen the multiplication by exponential function also, है ना? Now moving on further, we will see some more properties of Z transform. So we'll see third property. Uh, Third property says that time reversal. So we'll see what happens when we do time reversal for Z transform. Time reversal. So time reversal means that when, if f of n is Z transform is f of z, so what will be the Z transform for f of minus n? Likewise, that we have seen in the Laplace transform, if it was converting to f of minus s. If you will see Fourier transform, it will be converting to f of minus omega. So what will happen for Z transform? So it will just reverse it like this. Okay. If f of n Fourier Z transform is f of z, so f of minus n will have Z transform f of 1 by z. So by seeing one of the question, we'll try to understand this property. See, one question we'll see. See, one pole zero plot have been given to you in your question. Okay, pole zero plot. Poles and zeros are there. Okay, this is your unit circle. Okay, so poles are where, so poles are, let's suppose two poles are in the center, है ना? And one zero, two zero, let's suppose there are two zero in which uh, here and here it is their value. Let's suppose it is value is j 1 by 3, j 1 by 3 and minus j 1 by 3 value is there, and one pole is here and one pole is here, है ना? And its value is j3 and minus j3. This will, and this is 0 point, है ना? So this pole zero plot has been given in your question, है ना, of a Z transform. So it is asked, is this signal f of n is even, question mark. Now we have to understand how we have to solve it, this question. What will be the approach for this question? Pole zero plot of a Z transform of f of n has been given, and the poles are here. So see, as you know that this is your f of z plane, yeah? Unit circle is there. This is z plane only, in which poles and zeros are plotted. Like in S plane also, poles are and zeros are plotted. Like this here also, Z plane, poles and zeros are plotted. So we can write this equation as f of z is equal to, see, poles are written at the downside and zeros are in the upside. Poles are at 0 point, so z minus 0, and how much are there? 2, so square will be written. Zeros are at j 1 by 3 and minus j 1 by 3, so we can write z minus 1 pole is j 1 by 3, and next 0 are z plus j 1 by 3, because minus minus plus है ना, so here okay. And next z minus j3 and z plus j3. Okay, this is the z transform or mathematical expression for writing this pole zero plot है ना, ये just we have written that value. Okay, this now see we can simplify it. We can simplify like a minus b, a plus b, so you can write as f of z can be written as a minus b, a plus b is a square plus b square है ना, so we'll write as a square sorry, a plus b minus b, a square minus b square, so minus of j 1 by 3, j square is minus, so minus minus plus 1 by 3 whole square. Okay, this is this, and here also z square plus 3 square you can write, and downstairs you can write z square. So this value can be written as z to the power 4 plus 1 by 9 है ना, sorry, z square plus 1 by 9, here z square plus 9 will be there. Okay, by z square we'll try to solve, simplify and solve, so we'll get as z to the power 4 plus 8, 82 by 9 z square plus 1 by z square. So what we'll get? We'll get as z square, see we'll divide it, so we'll get as 82 by 9, 82 by 9 plus z to the power minus 2 is there, 1 by z square, z to the power minus 2 is there. Okay, this is nothing but f of z. But acha, you know now that for even signals, what is the condition? Condition is f of n should be equal to f of minus n. This is the condition for even, we have seen in the module 1 also. So if we will take as z transform, then what we will say, f of z should be equal to f of 1 by z है ना, f of z should be equal to 1 by z. So let's put the value, f of z is there, so we'll put wherever z is there, we'll put 1 by z. So 1 by z square will be there, plus 82 by 9 will be there, plus 1 by z to the power 1 by z to the power minus 2 will be there. So we'll get answer 1 by z square will be there, plus 82 by 9 will be there, plus z square will be there. I think, is it the same value as we have seen in the fz? So as we can say that fz is equal to f of 1 by z, so this signal is even in nature है ना, this is even in the nature, this is the answer. Moving on to the next property, I think this property you have understood from question only. So next property we'll see, next property is let's suppose fourth property, we'll see multiplication by n. Okay, multiplication by n. So how we'll do it? See, multiplication by n means that if f of n is there, f of n, and z transform we have taken f of z. Okay, so if we'll multiply n into f of n, what we'll get? We'll get minus z df by dz. This you should remember. Okay, this is the condition, or this is the multiplication by n property. So very important, many times you'll see this in the question. Okay, n into f of n is nothing but minus z df by dz. So we'll see from questions, we'll try to understand from questions, like see u of n is there. Okay, u of n, you know z transform is nothing but 1 by 1 minus z inverse है ना, it means z by z minus 1, and mod z is greater than 1. This you know already. If we'll multiply n into u of n, then what we'll get? We'll get minus z d by dz into z by z minus 1 है ना. So obviously we'll get as minus z will be there, and here first function, second function, so square will come here, z minus 1 into 1 minus z by 1 minus 0 है ना, this. So here we'll get minus z and z is cancelled, minus 1 is there, minus of minus plus, so z by z minus 1 whole square will be there, and mod z is greater than 1 still, because here value is z minus 1. So now first conclusion what you understood is, ROC does not change, by multiplication with n, है ना. अगर हम if we are multiplying n with our signal, so ROC value does not change. First property, first thing we should remember. And second is n into f of n is minus z f by dz, है ना. So this is there. If we'll see n square into f u of n, so what you will get, n square u of n is minus z d by dz of z by z minus 1 whole square. Now we need to take this value, है ना? We need to take this value. What we'll get as z by z plus 1, है ना? And here z minus 1 whole square. Okay, so sorry, cube, है ना? And mod z is still greater than 1, means ROC value is greater than 1. Okay, so see this property is not so tough. Just to remember that n of f of n is equal to z transform is minus z df by dz. Otherwise we need to only differentiate, rather everything is easy only. So we'll go with the next segment. Next segment is inverse z transform. Okay, inverse of z transform. So see, if I recall you that in that Laplace transform or normal Fourier transform, what we have seen, the inverse value, if we will take inverse Fourier transform, what we'll get, see, generally what we do is ft, if we'll take Fourier transform, we'll get f of omega, है ना. And now wherever we need to take from f of omega to inverse Fourier transform, है ना, inverse Fourier transform will get f of t, है ना. So like same way we'll get f of n is there, and we are taking discrete time Fourier transform basically, है ना. So sorry, not discrete time Fourier transform, we are taking now z transform. So we'll get f of z, है ना, f of z. Now from f of z, if we want to take inverse z transform, so we'll get as f of n again, है ना. So what will be the formula for getting f of, see, f of z getting is easy. We'll get as summation of n is equal to minus infinite to infinite, whatever f n is there, z to the power minus n. This is the value, this is the formula for getting your z transform. But if you want f n from f z, so what we'll do, for f n from f z will go 2 pi j, है ना, summation of f z, है ना, z to the power n minus 1 dz. This is the formula for inverse z transform. But by going this method we'll face some difficulty. So there are some easier way also. So we'll try to see by seeing one question, and then we'll try to understand. Let's see one question. See, if you have been given a question as f of z is there, okay, and it has been given z by z minus 4 square is there, okay, and then z plus 3 and z minus 2 will be there. Now this is your z transform, this is your z plane, means values in z plane only. Now what you need, you find the inverse z transform. You need to find the inverse z transform. But as you have remembered the inverse Laplace transform also, we have seen that more than one expressions are there for inverse value, like taking f of t from f of s, है ना? We were getting so many values, different values based on ROC. So whatever condition will be there, then that ROC will be neglected. Some ROCs are not defined, so we'll neglect it. Like this, we come to the conclusion that which expression we can take. The same will follow with the Z transform also. If f of z is there, so more than one type of signals can have this same Z transform. Based on the ROC, it will be unique. Okay, so if the inverse Z transform is known, है ना, is known, and uh, it is two-sided. This is given in question that its inverse Z transform is two-sided. First of all, we have understood, and second thing is given that not defined for z is equal to 3 plus j2. So see, what we need to understand is, question is given, we need to understand, we need to solve f of we need to calculate f of n, है ना? F of n, and multiple f of n will come. So we know that f of n will be two-sided, and it will not be defined for j3 plus j2, z is equal to 3 plus j2. So now we will try to solve our question. We'll try to solve our question, like, see what will be the approach of this question. First of all, we'll see that we can see that this its z plane will be there, z plane, and we'll try to plot some of the proper poles. See, z is equal to 4 minus 4 square, means z will be pole will be at 4. Two poles are there. So let's suppose that two poles are there at 4. So we'll do at z is equal to 4. Okay. Now see, we'll see at z is equal to minus 3 also some values are there. So at z is equal to minus 3 also we'll see, and see, z is equal to 2 also some values are there. So we'll take at z is equal to 2. Okay, so fine, these values are there. So see, actually in z plane, see, z is equal to plus 4 or minus 3, these values are not in the left hand side or right hand side. I'm just plotting like this only. The mod value, this value represent mod value, means the radius of the circle. So actually minus 3 means that 3 radius 3 circle of radius 3 will be like this, है ना? Circle of radius 2, circle of radius 4 will be there, but all circles or all radius are outside the r is equal to 1, as you can see. We'll try to plot. This is z is equal to 2. So acha, we'll plot like this. From here we'll plot like this. Z is equal to 2. So we'll plot as z is equal to 2, है ना? Z is equal to 3 also is there. So z is equal to 3 circle is there, and z is equal to 4 also there. So we'll plot as z is equal to 4 also, है ना? This value is there. Okay, and where is your z is equal to 1 unit circle? It is, let's suppose this is z is equal to 1. Sorry, 1 minute, sorry. I am thinking right. Z is equal to 1. Okay, sorry, it is right only. So see, this is z is equal to 2, है ना? This is z is equal to 3, z is equal to 4, and z is equal to 1. Now see, how many ROCs can be formed? Tell me. If all are causal, then obviously ROC will be this side. So ROC 1 can be considered, all are causal, and all 3 portions are causal, and it will be right hand side. So the right hand side to the greatest pole, so it will go like this. Maybe all are left sided, so it will be like this, all are left sided. So this will be ROC number 2, है ना? This will be ROC number 2, all will be left sided. So it will be overall left sided to the or inward to the least pole. Okay, and one more condition is there, that ROC can be formed in between. ROC can be formed in between. So ROC number 3 can be seen, and one more ROC is there. ROC can be formed in between 2 and 3, so ROC number 4 can be considered. So see, I'll tell you, I'll write you ROC number: ROC1, ROC2, ROC3 and ROC4. Now see this value sigma, not sigma, I will write at okay, mod z, mod z mod z value. So mod z value or R value, one ROC is mod z is greater than 4, है ना? Second number of ROC says that mod z is less than 2. Third ROC says that third ROC is between 3 and 4. So mod z is greater than 3 and less than 4. And ROC number 4 says that mod z is greater than 2 and less than 3. Acha. Now these possible 4 ROC can be formed from seeing this expression. From this expression, these ROCs can only be formed. Acha. According to question, which value will be applicable? See, first of all, we know that its inverse Z transform is known for it is two-sided. So obviously this cannot happen. This cannot happen. है ना? So obviously maybe this condition can be satisfied or this condition can be satisfied. Okay. Okay. So see this or this value, and now again you have been given in question that z is not defined for 3 plus j2. So see, z is equal to 3 plus j2. So what will be mod z value? Mod z value will be 3 square 9 plus 2 square 4. It means under root of 13. See, 13 is nothing but, if you have not, if you don't have calculator, just by mind you can see mod 13 is obviously greater than 3, because 3 square 9 and 4 square 16. It is mid between 3 and 4. So ultimately somewhere in this, in between it pole value is there. So means this portion is not defined. So obviously from 3 to 4 value is not defined according to question. So ultimately what is left is mod z is greater than 2 and less than 3. So see, now you can understand that see, if you'll do partial fraction also, or if you'll separate it out, what will happen? So see, first of all, I wanted to tell you that this expression was there for calculating your inverse Z transform, but if you'll keep this value and integrate it, it will take so much time. So what we'll do, first step will be, see, f of z was there in the question. So what we will do, we'll take this z value na at the downside of f of z. Why we are doing? Because it will make us easy for partial fraction. This will do partial fraction, then this z will cause nonsense. So we'll keep that z downside. So we'll keep like this, f of z by z will be equal to 1 by z minus 4 square, है ना, z minus 4 square, z plus 3 and z minus 2. Now what we have done, just z we have transferred here. So now we can do partial fraction. Let's suppose a coefficient is there, z minus 4 plus square term is there, so b z minus 4 square will be there, है ना, plus c by z plus 3 and d by z minus 2. As you know that taking out coefficient is easy. Just you need to do here and this value, and we need to just cancel out this value. Like see, z of plus 3 is there. So for taking out c value, so we'll cancel out z plus 3 and by all value we'll keep z is equal to minus 3 value, and we'll check what is the value coming and we'll put it here. So okay, let it be whatever value may be. Now I'm not focused on the coefficient value. I need to tell you that how we are doing inverse Z transform. So this value is there. Okay, now what we can do is we can take our z value again to the right hand side after partial fraction. So again f of z will be there, so a will be there, but z by z minus 4 will be there, है ना. b will be there by z minus 4 square will be there, plus c by z plus 3, and plus d into z by z minus 2. Now see what you need f of n, है ना, f of n you need. So ultimately you need to take inverse z transform. See, as you know that 4 to the power n u of n, what will be z transform? It will be z by z minus 4. So is it this one? So we can put value as 4 to the power n u of n. Acha, u of n will be there or u of minus n minus 1 will be there, because see, as z minus 4 means pole is at 4. So ultimately what we have seen the ROC is it is the overall means overall ROC is less than 3. Ultimately it will be less than 4 also, means see, if ROC is inverse from 3, so obviously the ROC of 4 will be also inward only. That is why when both are inward, then obviously that the least pole from least pole it will be inward, है ना. जब दोनों ही अंदर की तरफ आएंगे तो ऑब्वियसली 3 से हम अंदर की तरफ ले लेंगे, क्योंकि हम 4 से नहीं ले सकते. वी कैन नॉट टेक फ्रॉम इनवर्ट फ्रॉम 4 बिकॉज इट विल इंक्लूड पोल, एंड ROC cannot include pole, इसीलिए हम लोग will take from 3. So ultimately if mod z is less than 3, so mod z will be less than 4 also. So ultimately it will be inward signal. तो हम यहाँ पे लिख सकते हैं -4, और we need the same expression. So what we can do, -4 to the power n u of minus n minus 1. This we can do for the, because see, 4 to the power n u of n or -4 to the power n u of minus n minus 1 value will be same. Only this value will have mod z is greater than 4, and this value will have mod z less than 4, and that only we want. That's why we are taking this value. Okay, so see, now this value is there. Okay, fine, we have got this. Now for this b also the same value will be happening. So minus b, a will write here, minus a, b is there, and see, actually it is a square value. So you know that whenever when square will come, when will multiply n, see, n into u of n, है ना, n into u of n, what will get, z by z minus 1 whole square, है ना. Like this will get n into u of n. So like this we have multiplied n here maybe. So n is there, okay, and now 4 to the power n u of minus n minus 1 will be there only. For c value will get, see, for c value will get as c is there only, है ना. अच्छा, z 3, z plus 3 means pole at -3. So this value, it should be 3 value, it should be inward only. So here also we'll take same thing, like and poles at z plus 3. So we'll take here at -3 to the power n, है ना, and u of minus n minus 1 will be there, and this will be negative value, है ना. Okay, now final for z minus 2 means pole at 2. So it will be outward means u of n will consider. So we'll take as d, and how many values are there, what values is there, z minus 2 is there, na, sorry, z minus 2 value is there. So what we can keep here is 2 to the power n, 2 to the power n, 2 to the power n u of n. So this is the final answer which we wanted. How it came, see, and it is unique. It is unique because why it is unique? Because in the question itself it has been given that it is a two-sided. If it was not given that it is a two-sided and not defined, these conditions are not there, then we would have 4 ROC, means 4 inverse Z transform can be calculated from this expression. So in objective type of question you will be given some of the condition, and then you need to check the answers, है ना. Okay, so see, if I'll give you some condition, just check that if you are able to understand these conditions or not. We'll see some condition, like see, the same question is there, and if you have been asked to find that I'll take red pen. So some questions are there. You just tell me the answer. If inverse Z transform f of n is to represent impulse response of a causal system. If you have been asked that for causal system, which ROC or which inverse Z transform is to be taken, then your answer would be, just pause your video, think over it, and then see the video. For causal, obviously all signals are right sided, so obviously we'll take as ROC number 1 है ना. ROC number 1 will be taken as the ROC for causal response. Okay, if you have been asked that tell me which inverse Z transform will be taken so that DTFT is defined है ना. DTFT is defined. So as you know that DTFT is defined when Z transform is taken at r is equal to 1, means at r is equal to 1 means radius 1 circle है ना. Radius 1 circle should be included, and in which Z transform this value is included. So see, if you'll see mod Z is less than 2, mod Z is less than 2, this condition will be satisfied in all the 4. So ROC number 2 will be taken, ROC number 2 will be taken for DTFT. If I'll tell you that please tell me that inverse transform is defined for Z is equal to -1 minus J3. So -1 minus J3 will take 1 square plus 3 square 9. So it will be under root of 10. So it will be more than 3 and less than 4. Again more than 3 less than 4. So again we'll take what ROC we have taken now. So we'll take again ROC number 4. And then if you'll be asked that which inverse Z transform will be taken if your impulse response will represent anti-causal. Anti-causal, as you know, I have told you in the last module also, anti-causal means just opposite of causal. So obviously opposite of causal is ROC number 2 only. ROC number 1 opposite is ROC number 2, so we'll take as ROC number 2. So see, by seeing so many conditions, now you are able to identify which ROC is to be taken, and if you are able to identify which ROC is to be taken, then you will understand which inverse Z transform will be taken. So ultimately unique inverse Z transform can be formed by seeing the conditions, otherwise you will have so many inverse Z transform. So this is there. Now we'll see one more property. Let's suppose fifth property will be there, that is convolution property. Convolution property. See, it is very easy, no need to go further. See, convolution is nothing but if f of n is convolved with h of n, that is signal is convolved with impulse response, you are getting the output response as y of n. Earlier we have seen in Laplace also and Fourier transform also we have seen the same. Here also we will see the same. This Z transform is f of z, let's suppose. This Z transform is h of z. So in time domain, if we'll convolve any signal in frequency domain or Z domain, you can say that we can just multiply it. We'll just multiply it and then we'll get Z transform of output. This is the convolution property says that convolution in time domain will lead to multiplication in the frequency domain. So this is the convolution property, and tell me what will be the ROC if this signal has ROC as let's suppose ROC1. ROC1 is there. Let's suppose this signal is having ROC number 2. Okay, so overall ROC will be common to them, means see, overall ROC will be just multiplication of them. Total ROC will be multiplication of fz into sz. See, f of z will have some poles, so that it is having some ROC. It will have some poles. So what will be common and what will be the inverse Z transform, what we will take? So we'll see the common ROC will be taken. Like, see, we'll see one question, and we'll try to understand what it is trying to say. See, you have been given in your question that you have given a signal f of n will be 3 to the power n u of n. Okay, this is your f of n, your question, and your impulse response is nothing but h of n is nothing but 2 to the power n u of n is there. Okay, f of n is there, h of n is there. Now what you need to calculate, you need to calculate the response of, calculate the response of the response of discrete time LTI system, discrete time LTI system, ठीक है, whose input and impulse response has been given. Now you need to calculate the response. See, whenever you have been given this type of, and you need to calculate the response, obviously that whatever the response will be, it will be convolution of f of n into a convolution of n of n and h of n. So we can take convolution property and we can write here as f of z into h of z. Okay, so we'll get as y of z, and then we can take inverse z transform, we'll get y of n. So what will be f of z? You calculate? 3 to the power n u of n is nothing but z by z minus 3 with mod z is greater than 3, है ना? And you can write here 2 to the power n u of n is nothing but z by z minus 2, and mod z is greater than 2. So ultimately what will be the ROC? See, one will be at z z is equal to 2, है ना? And here this value is z is equal to 3, and unit circle is here. So see, mod z is greater than 2 also, mod z is greater than 3 also. So ultimately we can take mod z is greater than 3 because all are outside only, outward. So we can take, so like this ROC of common things we can take. Now as we have understood this, now we can take like this. For inverse z transform, what I told, just first of all you need to one z you need to keep here downside, so it will be z by z minus 3, z minus 2, and now you have to do partial fraction. So partial fraction can be done like see, you'll have as 3 uh, 3 uh, 3 z minus 3, and then we'll have 2 z minus 2. You can do partial fraction, you will get it this value. Now what you'll do, you'll keep this z value there, so we'll get as fz is equal to 3z by z minus 3 and minus 2z by z minus 2. So ultimately what you'll get, your f of n, if you want f of n, then you'll get 3 is there. Okay, and now you'll get z by z minus 3, obviously 3 to the power n u of n, or this will be u of n only because all are outward only, so 3 to the power n u n. So 3 to the power n u of n can be written like this, and then we can write as 2 minus 2, and here 2 to the power n u of n is written. Okay, so see, you can write as 3 to the power n plus 1 u of n minus 2 to the power n plus 1 u of n. This is the answer, very easy. See, so from here you can calculate the response of a discrete time LTI system, very easy. How to calculate ROC also I told you, and then how to calculate the response also, very easy. Okay, so today we'll close by this lecture only, because next in the next lecture we'll see some, okay, one more portion we'll see, then in the next lecture we'll see another, that is time shifting property. Okay, so we'll see sixth property as time shifting property, and then we'll close time shifting property. Okay, time shifting property, what it says that, let's suppose your signal is f of n, f of n is there, and its z transform is f of z. Okay, no problem. If you will shift in time domain, if you will shift in the time domain, what will get, f of z will be there, and z to the power minus n naught will be there. Okay, and whenever I told you in time domain, whenever we are shifting and a t minus t naught, then what we are getting is whatever sign is there, the same sign will follow in the the power part. Okay, power, in the power the same sign is there. So this you need to remember. Time shifting property is like this. See, if I'll tell you f n plus n naught is there, then also you will take z transform as f of z, z to the power n naught will be there. So what will be the sign will be there, that same will follow on. So we'll take one example. Let's suppose u of n is there, u of n. So its z transform is 1 by 1 minus z inverse, hai na? So what we'll get, okay, and mod z is greater than 1. So if you'll do u of n minus 1, u of n minus 1 will get, so what will get, 1 by 1 minus z inverse is there, and z to the power minus 1 will be there. Okay, because here minus 1 will be there, so minus 1. So like this can be happen, no problem. F of n is there, f of n minus 2 is there, f of n minus 2, its z transform will be f of z will be there, f of z will be there, and z to the power minus 2 will be there. So like this time shifting property occurs, and this property will be helpful for we'll see transfer functions also. So it will be helpful. We'll see in the next class direct form 1 and direct form 2 of block diagram, and then we'll see the time differentiation and time integration property, and what are bilateral z transform, unilateral z transform, and then we'll close up by initial value and final value theorem. So hope so next, in the next lecture we will close up this z transform chapter, and we'll go for next module, that is miscellaneous one. We'll see there DTFT, DFT, FFT, and group delay, phase delay, these all properties we'll see. So if you have liked today's video, if you have gained some knowledge from this video, then do hit the like button, do share it with the needy students, and if you have not subscribed the channel, then please subscribe it, so that you can get the latest notification from the channel. So till now this much only. We'll see in the next lecture. Tata, bye bye, see you, have a good day. Jai Hind.